The internet today has been described as this big nervous system for humanity, right? So much of what we do today is carried through these digital pipes. So much of our economy is just run entirely on the internet now. And we interface with the internet and with each other through a series of applications. And these run mostly on the web. The web is sort of like the transport protocol for how these applications move around. It's a way of being able to deploy different media and to be able to move, to link people from one set of things to another, to put people in applications, and to give people functionality that they didn't previously have. So it's like the page just loads and you retrieve some new functionality you didn't have, and you now can access new things, right? So this was a huge breakthrough, of course, but it has some problems today. Now, the crazy thing about the internet and the web is that it's just a collection of protocols, right? So it's a bunch of really good ideas of how to do things that have worked, things that haven't, that get standardized, put into browsers and put into other tools and into computers. And then this orchestra of programs runs and gives us this amazing range of capabilities, right? So everything that we as humans can do today, be able to learn remotely, be able to think together, be able to talk to a person around the world, happens thanks to these great protocols that have been written by people that really were just aiming to augment their own experiences, and through that ended up augmenting what the rest of humanity can do. So this is kind of mind-blowing, right? Because it means that if you find a problem with the internet, or you have some new ideas about what humanity should be able to do, you can just write a protocol, and then you implement it. And if you're right, and it works, then you tell the world, and then it gets deployed, and then a lot of people will use it, and the world will be a better place. So it's a great place to be. Now, we have found some problems that we're now telling you about, and they mostly have to do with how we move applications through the web. So it's moving not just applications, but any kind of media. So documents, images, pictures, images, video, and so on. So IPFS is mostly related to HTTP, and it sort of enhanced HTTP and should be used alongside it, or maybe as a shim, and potentially in some cases, like actually just transition over to using IPFS instead. Now, the big problem behind this change, or what we're trying to solve here, is the problem of using location addressing. So if you've looked at a URL, you have this first part of the URL that's the domain, right? And that's here it's example.com. The domain is resolved to an IP address, and an IP address means the set of numbers that you need to dial to get connected to another computer across the network. So what does that picture look like? Say that you're here, highlighted in blue, and you're trying to access this picture through the internet, and you have an address, and this address has these numbers and then a path for the actual file. That means that you're going to find a specific other computer at that address and fetch the image from that computer. Now, suppose that all of the other computers pictured here had the exact same file locally, including one that's very close to you in the network. Perhaps maybe it's in the same room, but it doesn't matter. As far as HTTP is concerned, that is not the same file. And you have to go across the world to 10.20.30.40 to find it. Actually, that's probably won't resolve because 10. Is a local address. But anyway, the issue here is that we are addressing content by location. So we're telling you where to find something instead of what it is. And a lot of people have talked about this as a problem and come up with solutions, but it hasn't quite sunk in. And so to drive more the point here and to show you why this is actually a huge problem today, picture a big room of people, and it's filled with people with a bunch of computers. And nowadays we carry a laptop and maybe a mobile phone, and soon a watch, and we'll have a bunch of devices. Say that I upload a picture to Facebook, and I give everyone the link, and now a whole bunch of people are going to go to Facebook and fetch that image from Facebook all the way back. So, not that big of a deal, right? Well, let's look at how it looks in the backbone. So I make a request to Facebook and I send it up, and say it's just a 1 megabyte image times 8 here because there's a set of, say that there's 8 links. So it's the total amount of bandwidth. These are really rough calculations just to give you a picture. Say that there's 8 megabytes of bandwidth used by my picture going all the way up to Facebook. And when 30 people show up, say that they're all in the same room, and they all talk to Facebook and all pull down the image, now that's 240 megabytes of bandwidth wasted. And you might say, well, that's unavoidable because we have to encrypt everything, and that's true. We have to encrypt everything, but we have to ship the image 30 times across the wires. Doesn't matter if it's wasted. Like, you just have to send it. Maybe that's true. Maybe that isn't true. And you know what? Well, maybe 240 megabytes is not a big deal, right? But what if we're looking at video instead? So imagine that you go to YouTube and you start watching a video, and it's in high def. So say it's like about 200 megabytes, and you send it to everybody else, and then like these 30 people start downloading a 200 megabyte video across these 8 links. Now we're talking about 48 gigabytes of bandwidth. That's starting to be a lot. When you look at bigger files or like longer videos and so on, we're looking at potentially terabytes of bandwidth needed just to move these files around from the place that they're needed to the backbone and back. And the crazy thing is that those same files, or the same data that represents those files, might be lying around in the same local area network that you're in. So it really, like a computer right next to yours, could be serving you that file. Now, there's a lot of reasons why we haven't done this historically, but it may start to be a good idea. That was intense. So while we're talking about bandwidth, let's look at something else and kind of why this is a problem. So this is data from Akamai, and it's a graph from 2007 to 2012. We could update it, but this is kind of an older graph. And in that period of 5 years, bandwidth only improved about 1 or 2 megabits per second in the G7, and that's the 7 largest economies. So that is not a very significant improvement. When you compare that to the way that our storage is increasing, right? We now have 10 terabyte hard drives. We had 1 terabyte a few years ago. We're going to have 100 terabytes in a few more. I mean, it's the cost is doubling, halving every 11 months, and we're now looking at big numbers. So that means that we're saturating these pipes, and the bandwidth from the local area networks to the backbone is really, really, really small compared to how much we want to use them. And actually, the problem is worse because the rate of improvement on the speed of connections, of the average connection, is actually improving at a slower rate than storage. So that means that people are getting larger capacity drives faster than they are getting better bandwidth, which gives you the impression that things are getting slower. Because in a sense, you want to use more of the network. There's also another problem, which is latency. And I mean, we've all known for a long time that we can't get around the fact that the speed of light remains constant. So the only way to make things faster is by moving them closer to you. This is why Amazon and Google have offer these cloud services that you can hire to store a whole bunch of stuff right next to where it's needed the most. And this works pretty well, except that sometimes sometimes people don't have things deployed in those locations, or even that latency out to through these slow pipes to that data center is too much. I mean, maybe what you need is the file that you need is literally in another device in the same room, and instead you're piping the data through the backbone. You're making a request out to the network, grabbing the file, and then pulling it down, instead of just talking to the other device that you have locally. And this is kind of an absurd thing that we do this. And kind of a funny anecdote. I was giving a talk once recently about IPFS, and the slides that I wanted to present were stuck in my computer, and my computer couldn't talk to the projector because we didn't have the right adapter. And getting my slides from my computer to another person's computer required, because nobody had a USB key, required sending the slides all the way up to the backbone and then back down. and like it didn't actually. Most people would have had to do that. Like we actually just drop into the terminal and just like connect to the specific computer directly and so on. But this is the kind of stuff that we're dealing with. Like the average person doesn't know how to do any of that. There's another big issue here, and that's the dichotomy between online and offline operation, right? So we as engineers are sort of misusing the web because we program behind this model of saying, we have this data center, and if the user can talk to the data center, then they're online. And if they can't, they're offline. And this is actually a pretty bad model, and increasingly it's becoming more and we had this perception that it was going to get more and more true, as in, we're going to connect everyone and everyone's going to be online all the time. But that's actually not accurate, because we have ever more devices that we carry around and contexts which we're using these devices that are not close to any kind of network that can move us. So imagine that you go on a plane and you're traveling and you have your laptop and you have your phone and maybe you have some files in one and not in the other, and now like moving those around, like most applications that you have are not going to do that. In fact, certainly most applications that you use through the web are certainly not going to load. They're not even going to load. Most things just cease operation the moment that you step outside of the bounds of the network. And sort of to illustrate how this works, like imagine you have again this like massive classroom. By the way, this classroom is great. It just shows so many of these issues, right? Say that I open a Google Doc or something, and I send it out to everyone else, so everyone opens this Google Doc, and now we're all collaborating. But all of these updates are getting shipped out to the backbone, to some Google server, and then shipped all the way back. And so that's how we're collaborating. So by the way, we're seeing a lot of latency there, because every single time you type something, it has to go out there and then back instead of right next to you. You could be literally sitting next to the person, and you still have to go out there. And we've kind of hidden behind the fact that humans don't perceive that much latency, and if you get around 300, 400 milliseconds, like you're barely going to notice it. But say that something bad happens to the rest of the network, and this whole room loses connectivity to the backbone. Suddenly, the entire application comes crashing down, and nobody can do anything. So maybe they can keep editing things locally, but they cannot ship the updates that they're making to the person right next to them. And this is absurd, right? I mean, talk to any person who's using these applications, they think it's crazy that the data from one computer can get to the other computer, which is right next to it. And in reality, these computers are actually talking to each other. They're on the same network. They're probably pinging each other, or they're seeing each other's packets flowing through. We just haven't taught our applications how to have them talk about these files. And this problem is all over the web. I'm not picking Google here. Like look at tons of applications that we use day to day and like run our lives are cease operation entirely. In fact, actually, Google's one of the best on this. They have this awesome technology called operational transforms that allows these updates to be done concurrently and like to give you this amazing impression that it's working all flawlessly. And they all get applied in the backbone, and you can be editing the same document, and it just works flawlessly. They could be sending those updates to each other through things like WebRTC and so on. But as far as I know, that doesn't happen, and it certainly doesn't happen in most applications that you see in the web. And this is not a flaw of the protocols themselves, in that we sort of could be using WebRTC nowadays, but it's actually a flaw in how we store data and how we reference data. So it's how HTTP has taught us to store data on the web and reference it. And since the beginning of HTTP, like W3C has actually come up with a whole bunch of new ways to reference data that are better, but people haven't really adopted them in the web. Now, to me, this set of problems kind of feels very silly, right? Like you have this massive set of computers somewhere, and then you take out the mothership, and everything grinds to a halt. And most people think this is fine, but in reality, we enter terrible bandwidth problems. We run into these issues with being somewhere between the online-offline spectrum, maybe we're in like a very low bandwidth setting, or we have a bunch of interference, or there's congestion, or maybe you're traveling, like I mentioned, or your ISP has intermittent outages. This happens to me all the time. And maybe the data center has some problem, right? So many issues could be occurring, and users can't be forced to halt their operation just because there's some discontinuity between them and the backbone. So our applications should learn how to operate in entirely distributed settings, and we as engineers need to start doing this, and we need to build better tools for application developers to do this. Now, it's actually really important, right? So you might think that I'm just talking about these problems that we want to improve, but they really, really matter. And they matter so much that if you ask any Egyptian about the time that the internet shut down because their government decided they were not going to allow communications, they are going to tell you very seriously that these applications either potentially save their lives or their families' lives. So these are not only mission critical to businesses, they are mission critical to human lives potentially at risk. So these particular communication things need to be able to speak to each other when disconnected from the backbone. We need to be able to have our computers talk to each other. And we need to be able to do so securely, right? So we've seen this, in the last few years, we've seen like the great failing of our community in terms of securing everything. We've had major breaches described, by Snowden and so on. And there's all sorts of problems with how we're moving around data on the web, and it's really not enough to encrypt the communications. I think it was a couple of years ago, or maybe not that long. Dropbox had this huge data problem where they allowed anyone to log in for something like 4 hours, and anybody could log into your account and look at your files. And that was, Dropbox is full of great engineers, and this is kind of like, if they are not getting it perfectly right, imagine how many people are just getting it totally wrong. So we need to be encrypting everything, or really looking carefully at how we're doing security on the client side, and treating the cloud as just, as much as we possibly can, treating the cloud as just oblivious storage or oblivious routing systems. And this of course complicates everything, but certain kinds of applications or certain kinds of context for applications demand that kind of attention. Now, the last one I want to talk about is permanence, and this one is really, really deeply important to me, and it might not be as obvious to everyone why this matters, but I'll try my best to illustrate it. So think about book burning for a moment. Think about the most important piece of media that you can think about, like the most important book that you've ever read, or think about all of Wikipedia, and imagine someone coming along and burning it and really destroying it, making it impossible for anyone to read ever again. Think about all the knowledge that is lost. Now, historically, we've treated book burning as this insane, crazy offense to progress and into humanity itself, and we've condemned anyone who's gone to do such a thing. And it's kind of and when you look throughout history and you look at the occurrences of book burning, they drop off significantly with the advent of the printing press. This is because the printing press allowed you to make many copies of the same book very cheaply. So, say that you print a whole bunch of copies and book burners show up and try to burn a lot of books. Well, they're probably only going to be able to get to a few of them. Or even if they get most, there's probably copies that are going to survive, and you'll be able to make more copies. So this is great. Now, we have some problems today because, if you've been around the web, bringing this back to the digital world, if you've been around the web, you've probably seen a 404, right? A 404 is an error that tells you that some resource is not found. What that means is that there was a link pointing to another object, and that object is either no longer there because someone took it down, I burned the book, or someone moved it. And we tend to talk, we tend to chastise a lot of agencies and so on for taking certain content down or censoring and so on. But we forget that there's a tiny little book burnings happening constantly whenever any web developer moves some content from one location to another. Any link that anyone had added to that location is now broken, and it is potentially findable through search, but not going to be, that link is now no longer going to work. Potentially, because we have the system where both the publisher of content has to host it, or make sure that it's hosted somewhere, the consumer of the content must depend on that producer keeping that content up, or they have to copy it and move it somewhere else and give it a new address, right? So this is again like this is strongly related to the location addressing problem, and it's sort of behind this. This is why links break, because people end up being careless and moving things around. And really thinking of the web of documents as in the abstract, kind of ignores the fact that really the web is not just a web of documents. It's a web of documents on machines, and that the notion or description of a document identifies the set of machines that are responsible for keeping it up. And this prevents people from replicating or being able to host the same content somewhere else. This is kind of like a book burner's paradise. And I'm describing this like accidental book burning that happens. Now, fortunately, someone, a group of people, very smart, saw that this was a pretty big problem early on into the web's history, and started trying to archive everything. And of course, I'm talking about the Internet Archive, and it looks like this. It's beautiful. If you haven't been there, you probably should. And they are running this project to try and index the entire web and store it, store every single page that they can possibly find and store it, because they know that stuff will be needed in the future. Ironically, I was trying to find the source code for one of the protocols that we learned a lot from and used to develop IPFS, and funnily enough, the source code is only available through the Internet Archive, because the people that were hosting the code no longer are hosting it. Or maybe there was some glitch in the server or whatever. We could only find it through the way back machine, which is this great service that they run. This is actually very closely related to another important problem described by Vint Cerf, who's one of the creators of the internet. And that's this notion of digital vellum. And think of old computers. As technology evolves and gets better with time, we stop using the old things. And so much so that we stop being able to give them maintenance, and sometimes they break. And when they break, nobody knows how to fix them, or nobody has the parts to fix them. So these old machines that no longer work may have been readers of important media. So things that we stored in some physical material that this computer or this machine was going to read out to us. And now the machine's broken and nobody knows how to fix it. That means that all of that content is lost, completely lost, unless we find a way to fix it. And so, the solution to this is really learn to emulate everything, right? So we as a society should be very careful with the types of media that we store and how we store them, to make sure that, even if we stop using something or some major problem happens, we can emulate all of these computers or machines that were old, to try and read the encodings or be able to read out this media. And so we need to be able to simulate or emulate every single computer that we've ever built. And this is again related to this book burning problem, because say that we do this, say that we create all these emulators. Where do we host them? That location might be taken down. So we might be taken down, or maybe might lose funding or whatever. We need to be able to replicate these systems and store them in as many places as we possibly can. And we need to build tools and make the internet capable of doing this very easily. So these are the problems that have driven us to think through how the web works, think through how content moves around in the internet, and come up with a solution. And this isn't designed sort of in the abstract. We're actually we thought for a long time, and we thought through many different kinds of attempts and solutions to this problem. to try and synthesize a bunch of good ideas that work well together and provide some new software that, so both a protocol and tool set that people can use to make the web better.